Continuing right along, and more excited than ever, this form is just insanely awesome. Got a little curvature going there. Probably can get off that and that. And I have another, I was doing lots of finishes on here with the analysis tools, which I found interesting. Got a Z map on there. No, that's the curvature analysis. It's basically a zebra. What I want to show you what's going on here is this form is absolutely perfect. Look at it from the top, look at it from the sides. How is created? A little bit of Python will make your geometries immaculate. So I'm doing exactly what I said. I'm taking the scripts out of this Chinese text on GhPython. I'm converting it from Rhino syntax into Rhino geometry, and I am importing math, and I am having a blast. I have dug up a book that I have not thrown away since I was 17 years old, Journey Through Genius, that my father gave me before I went into mathematics at Waterloo. And then I have my calculus book and my faculty of mathematics book from 1991, whereupon I dropped out in my third year because none of this visualization tools was there for me, and I entered a year, maybe 2 years, and then 30 years of printmaking, sculpture, mysticism, magic, the occult, film studies, and what have you. Enough said. Here we are. We're taking a look at this script, and it is dead simple. So I have it on a ink tool, I have it on perspective, and I have it on rendering. So let's put it back into shaded and see what we have here. Let's take our object, go to visibility, get rid of it like normal, and pop back on our ghosted form in Grasshopper. The only things I'm showing in this script are, and I'll move this down so you can have a look at it, is I'm visualizing, not just keeping the Python script up, but what I'm doing here is I'm keeping up the initial shape that I generated. I'm keeping up the vectors displays of what the offsets are for the extrusion, and I'm keeping up the extrusion tool. The whole second part of this script is a snippet that I use constantly over here in Surface Edit. Extrude surfaces along normals, which is extrude surface normal 002. It's a simple script that offsets and does a really nice job of taking a untrimmed surface and extruding it. But the whole script here that I generated this from is what I really want to look at. So I'm going to take this and I'm going to hit disable. We're going to come back down to this initial shape right here, and you're going to see how that actually is created. And it is created from a Python node. And with my scripts, I want you to look at the stoplight red, the yellow to get ready, and green to go. So you've got your Python, you've got your parameters, and you've got your effects afterwards in Grasshopper going to a lofted surface. Very simple Grasshopper following a very simple Python script and producing a beautiful, in my opinion, geometry, closed watertight geometry. And here's the script. I went in and I brought in a Python node and I took everything to what it has to be. Let's just start with it. I imported Rhino Geometry as RG. I imported maths. I made a points as a list, a blank list. And for I iterated through, not just to a stop, but a start, stop, step, which I set in as integer values, as sliders. So as I play with those sliders, my geometry does fantastic things. Just fantastic things. As I change the setup of that, I end up with some beautiful forms. What a plate. What an insane, crazy, beautiful NURB surface. Can't say enough about it. And the step creates these wonderful ripples as it goes through. I think Daniel Christoph would be proud of me, at least my visualization skills, if not my mathematical understanding, which is nowhere close to his. And this just jitters and shakes as I amplify it. And what the amplification is doing is it's playing off of the I have to put the script back on to appreciate that. Enable. The amplification is a simple tool that's going to ripple and jump the math logarithm of I times amplifier squared. And that's just going to do some funny little rippling. And then I have also, this is parametric. The shape of this is also tied to the extrusion thickness. You got, you weren't ever allowed to make ashtrays in clay studies when I was in public school. This is the best ashtray I've ever seen in my life. So here it is. all the way running through to the final form. Let's break it down to what it was again. The script itself is an iteration through start, stop, step. So we're looking at the red and the yellow parameters. We are simply making a point in Rhino Geometry on point 3D and using the iteration I squared, and then the math of logarithm 10. And I'm appending that to a point system. What I'm doing is that actually is generating a very cool curve. So let's take this and put it on preview and turn everything off. That's what you're making. You are making a fantastic, simple line that does wild things. You can see that that just behaves in such a perfect NURBS curve kind of way. And I know that that simple geometry is what jazzes it up, and after you take it to a curve, you take it to a simple a polar array, then I dispatch and grab every second one, taking every other geometry and raising it up in a z tied to the parameter 12 through the z-axis, and I weave it back together. Now, that's one technique that I see used by Horikoshi Unikoro. Oh, I wish I had his name. Horikawa uses it all the time, the sense of dispatch and then weaving together. And then loft options is something that I can close this function, so I don't want to leave it open. Otherwise, well, I guess I could leave it open, but I don't want to. I want to close that back off and have a perfect geometry, a perfect surface. And that surface then jives through this wonderful shape of the whole thing by offsetting to a different value. You could really blow this up if you wanted to have a thick bowl. And then you can take as many for articulating it as it steps off and moves. Very nice structure there. Through as many divided surface. What is that? That's going into the divided surface tool, and it's also going into the U count on the surface from points. And it's a very simple system that I use for offsetting surfaces. An untrimmed surface into divide surface, into surface from points, into not the loft. I have to debrep. It's a little fancy footwork down here in the end, but I provide the GH file online. If you're interested in it, go ahead. But I am not about Grasshopper in this series. I'm not about the lofts and what's happening there, and I'm not really giving a tutorial to do that. What I'm trying to encourage is people to go in, open their Grasshopper command line, drag a GhPython node in from their math script section, and get to work in it and write these very basic scripts. I am going through the most basic things dealing with an array of point right now, and I'm going to introduce a conditional example into this. And once again, this is coming from this text. The ideas of the drive is coming from this GhPython text, but I am not copying and printing their codes. Like if using an I in range is plagiarism or taking from an idea, that's kind of ridiculous. It's like, what do you do with these most basic things? And even though I received a message from one of the members saying, listen, I have the book, I know all the contents. It's great to know all the contents and how to do it from scratch, which I'm not even capable of doing yet. But once you see it there, it's like, you don't want to start things with a blank tablet. I don't want to work in Rhino. I don't want to, when I do Grasshopper, I want to have a bunch of snippets and codes and scripts that I can pop on here that I've generated in the past. Here's Raya Isis matrices and GhPython, which is outstanding to grab that and start grabbing some geometries and information right off the bat. Different plugins, different imports. Ohm is just an incredible site for grabbing surfaces and snippets that I can use to get something going. And also with Python, I don't want to start with a blank script that says Rhino Geometry is RG and import math. I want to have something. I want to have a list to start with. I want to have some points down on there. I want to play with those. And I definitely, the end goal is to make some type of product or some type of sculpture, some type of outcome on whatever scale you think imaginable. So really, my other scripts, if you go into them, the key to this one is just to do something nice with the curved geometry coming out of the Python node, which is all it really produces. And as I get better, this interpolated curve will get scripted in Python. The polar array will get scripted in the Python script. The dispatch will get scripted in the move, the weave, the loft. That's going to happen fairly quickly. Things start to get very interesting as you start playing with conditionals. You can change geometries by just subtle maths. And what my mind is wrapping around is not the Rhino window, not the geometry the GH canvas, not the Python editor. It's going in particular after these functions and these namespaces of Rhino Geometry and trying to find out the power of a simple tool like this. And the reason I find that so interesting in all these scripts is because it wasn't too long ago, and I need to take that out, that I was jumping into Python, into Grasshopper, going to the maths, and I don't know why I'm talking so fast, maybe because our house is finally quiet, the kids are asleep, but I was constantly, from Daniel Christen's influence, going into the expression editor and trying to figure out all these incredible forms and what these do. This is where I go to understand the details of what some of these things might be doing. And there's even a wider range in here, but in the end, there's a much wider range in Python. So I'm destined to go there. I'm destined to develop, and I'm destined to make objects and commissions and start using computational design development to get things rolling into fabrication and installations, and try and get out there center stage again and make some art publicly. Thank you very much for watching. I'll leave that one saved in the file just so people know what I was kind of referring to. But a great little exercise. We'll turn back on the whole view of the object. I might even take it over to what the bake was. Actually, it might be best to leave this, put it back into all the views. I just think it's a terrific piece to go in and realize how that just rolls and turns and undulates up and down by simple logarithm and a couple of exponents, multiplying things by themselves, and then still maintaining a top view of a very incredible system. And of course, I can't switch anything out while it's running on turntable. I know that, and I never remember to do that. There we go. Beautiful top, beautiful form, and a lot of power over manipulating it and changing it. Red means go to the Python, stop and take a look at the editor. Yellow means play with the parameters. If it's not darkened out, you can take a look at the curves, the surfaces, the vectors, and the final extruded forms, and they will be put over in green if they're worth spending too much time looking at. So I hope my script is readable. I hope it's playful, and very excited to continue with this series. Like I said, I'm going to do some conditionals tied to these range functions next. 12 minutes. Thanks for watching.